The space economy is growing, and the value of services derived from space is higher than ever. But we can no longer afford to launch satellites that serve a single purpose and then become useless space debris at the end of their lives. To meet the world's need for more sustainable space capabilities, today's aerospace engineers are creating modular spacecraft that can be assembled and reconfigured on orbit. Spacecraft with upgradable components, refuelable spacecraft, large space platforms that serve as centralized hubs for science and manufacturing, and even space hotels. What simple component ties all this together? It's a connector. At SpaceWorks, we've developed FuseBlox, a purpose-built space connector for the world's on-orbit servicing, assembly, and manufacturing needs.
Hi, I am Kevin Okseniuk, and I am a program manager here at SpaceWorks. Today we're going to talk about one of our products, FuseBlox. FuseBlox is a modular connector system for in-space docking and assembly. There are many features that make FuseBlox a versatile system that is well suited for a variety of applications. FuseBlox is androgynous, it is self-aligning, self-grappling, and it is also tolerant to offsets and initial drifts in 2 axes. It also features a redundant electrical interface for power and data transfer. Perhaps most importantly, the current design of FuseBlox has been qualified for launch in operating environments from low Earth orbit to cislunar space. FuseBlox is ready to fly, and today we're going to show you how it got there.
The Air Force was looking for a way to assemble and reconfigure structures in orbit. We previously developed a novel in-space docking system called FuseBlox with the Department of Defense. With the Air Force Research Lab, we took FuseBlox further, producing and evaluating flight units against a battery of real-world tests. We established specs for docking performance, power, communications and data transfer, and for the overall environment. Things like temperature extremes, accelerations, vibrations, and the vacuum of space. We had to know that FuseBlox would perform as expected in space and could take whatever the universe could throw at it. FuseBlox met or exceeded all performance requirements.
We built some great hardware in FuseBlox, but it's the software that makes it move. The inner embedded software that tells the device what to do, including receiving commands, reporting telemetry, and making decisions.
When it approaches to dock, our client spacecraft needs to tell FuseBlox when to start that action. So for that, we developed a data protocol that uses CAN bus, which is a robust vehicle standard used in vehicles and industry across the globe, including satellites. In the future, we may add Ethernet as an option in order to increase compatibility with even more host spacecraft.
We brought the electronics through an iterative development process and completed a rigorous series of tests on the final product. The result of that process is a seamless connection between the software and FuseBlox's innovative mechanism, making integration to a satellite or platform easy. The innovative mechanism gives FuseBlox a big advantage for simulated space environments. It does not require electrical power to hold the docking connection.
One of the biggest advantages to the FuseBlox is its ability to be androgynous. When used in space, this flexibility means that either side of a FuseBlox pair is capable of docking with the other one. Of course, this is also one of the biggest challenges when designing the FuseBlox. Designing the claws or grapples to articulate in the way that we need, while still maintaining the ability to be male or female in gender.
Once built, it's time to test FuseBlox. Testing included vibration, thermal extremes, vacuum environments, and electromagnetic compatibility. Part of this testing was done in a thermal vacuum chamber to ensure survival in either full sun or full shade in space. This requires a pass-through electrical connection that would withstand the temperatures, pressures, and other rigors without leaking. These harnesses and this pass-through connection plate are some of the equipment used to accomplish this.
To ensure FuseBlox would survive the trip to space, we bolted it down and shook it like crazy to replicate the worst ride possible in a rocket. Separately, to test FuseBlox's docking capabilities, we ran tests in a virtually frictionless environment, mimicking satellite operations and movement in space. We set some pretty lofty goals for docking at large offsets and high speeds. FuseBlox exceeded all of our specifications. It's built to handle anything it'll encounter and can make up for some pretty terrible driving with successful docking.
We hope you enjoyed a sneak peek of how FuseBlox came to be. As I said before, FuseBlox is actually ready to fly. We envision this system becoming an enabling technology that could connect and aggregate new platforms in space, from satellites to telescopes to solar concentrators, human habitats, refueling stations, you name it. In the future, we also plan to add an interface for fluid transfer and an instrumentation suite for relative guidance and navigation. We want FuseBlox to become an all-in-one, plug-and-play connector that space architects can rely on to design the space platforms of the future. If you're interested in learning more, feel free to check out the website below or reach us directly at info@spaceworks.aero.